क्लास रेप्स, अभी तक मैंने उनसे कांटेक्ट नहीं किया है। What else is pending? Is there anything pending from my side? जो मैंने प्रॉमिस किया हो बट किया नहीं है अभी तक। तो टर्म पेपर तो देना है। अच्छा, एंड आई हैव केप्ट quiz also, my evaluation parameter, grading parameters.
Yes, sir.
क्विज रखा हूं तो क्विज लेना भी तो पड़ेगा ना। पड़ेगा तो आज ले लूं एक क्विज। आज ले लूं एक क्विज।
सर थर्सडे रखो ना।
क्विज नहीं हुआ ना। सो एक इस पे क्विज पे एक मैं तुम लोगों को एक जोक बताता हूं, बट you have to find out fallacy in the logic. So one teacher asked his class, yeah, next week I will take a surprise quiz. Okay? And it was 5-day week and 5 classes per week. और previous week के last class में teacher announced that I would take a surprise quiz next week. Fine. Monday came, everybody was ready कि हो सकता है आज surprise quiz हो जाए। ठीक है, तो and the teacher did not take the quiz. तो अब 4 दिन बचे, 4 दिन में किसी एक दिन सरप्राइज क्विज होना था। So Tuesday came and everybody was anxiously waiting for the quiz to start, but teacher again ignored. So Tuesday भी चला गया, quiz नहीं हुआ। Then Wednesday came and same thing happened. He did not call for any quiz. थर्सडे आया तो लड़कों का था कि अब तो प्रोबेबिलिटी वेरी हाई 0.5 कि आज क्विज होगा, सो आज तो हो जाएगा क्विज। तो टीचर ने उस दिन भी क्विज नहीं लिया। तो फ्राइडे को एवरीबडी वाज रिलैक्स्ड कि आज तो क्विज हो ही नहीं सकता है, बिकॉज टुडे प्रोबेबिलिटी ऑफ टेकिंग क्विज इज 1 and then it is not a surprise quiz. So nobody bothered. Many people actually were absent also in the class. Teacher came, he started teaching and everybody smiled कि ठीक है साहब, हमारा तो बिल्कुल प्रोबेबिलिटी जो हमने पढ़ी है उसके मुताबिक दिस इज अ वेरी गुड। And it is going as per our conclusion that there would not be any quiz today. और जब लास्ट में 15 मिनट बचा तो टीचर अनाउंस कि चलो अब हम क्विज करते हैं। Everybody was taken aback. They protested that this is not a surprise quiz, but he said that it is, because you are not ready for that, and that is what the definition of surprise quiz. I did not announce in advance that today I was going to take the quiz. Right? और उसने क्विज लिया. Many students blundered in that. Many did not participate because they were absent. So जो usual जो quiz होता है वैसा quiz हुआ. Now tell me what is the fallacy in this logic. The students were correct in anticipating कि अगर थर्सडे तक क्विज नहीं हुआ तो फ्राइडे क्विज नहीं हो सकता. And therefore Friday in any case quiz cannot happen, right? If Friday cannot happen, then remaining 4 days, in the remaining 4 days, again with the same logic, Thursday cannot happen, quiz cannot happen on Thursday. So Thursday and Fridays are eliminated. So now 3 days remain, Monday, Tuesday, Wednesday. If quiz does not happen on Monday or Tuesday, then it cannot happen on Wednesday. So Wednesday is also eliminated. उस हिसाब से लड़कों ने ये किया हुआ था कि क्विज हो ही नहीं सकता. अगर सरप्राइज क्विज होना है तो सरप्राइज क्विज हो ही नहीं सकता कभी. So what is the fallacy in this logic? Logic sounds good. जैसे अभी किसी ने कहा ना कि सर आप क्या कहा उसने, थर्सडे को ले लीजिए. थर्सडे को लूंगा, अगर मैं बोल ही देता हूं कि थर्सडे को लूंगा, देन इट इज एन एग्जाम, नॉट अ क्विज. कैन एनीबॉडी टेल मी व्हाट इज द मैंने लास्ट क्लास वाज ऑन 3rd of February ना, तो लड़कों को बोनस मार्क्स दिए YD 23 and 1. ठीक. सो बताओ क्या था क्विज में, उसमें फैलेसी. Meanwhile, let me share my top video. तो कोई बताना चाहेगा इसका आंसर, व्हाट इज द फैलेसी इन दिस लॉजिक?
हेलो,
बोलो.
मे बी टेकिंग ऑफ लिटरल मीनिंग. क्या आप तो एस्थेटिक्स होता है कि फिर नहीं हुआ है तो फिर हो ही जाएगा, कि आप लिटरली मीनिंग लिया कि सरप्राइजिंग है, बट आई थिंक इट शुड गो ऑन एस्थेटिक्स की लाइक बहुत ज्यादा लिटरल नहीं लेना चाहिए चीजों को.
नहीं तो तुम फिलॉसफी झाड़ दिया. बहुत ज्यादा लिटरल नहीं लेना चाहिए चीजों को. दिस इज अ फिलॉसफी, नॉट द लॉजिक. और एनी अदर आंसर? चलो इसका आंसर मैं बाद में बताऊंगा. सो विद दिस लॉजिक थर्सडे कैनॉट बी क्विज. थर्सडे क्लास में नहीं ले पाऊंगा मैं क्विज. देखते हैं थर्सडे को क्विज होता है या नहीं होता है. ओके, सो नाउ लेट मी स्टार्ट रिकॉर्डिंग.
Sir,
यस.
can I try for the quiz one?
हाँ बोलो.
So the teacher said that he or she will take a surprise quiz, right? So he meant that he will take a quiz when they are not ready. So the first 4 days they were thinking that the probability is there that today a quiz will be taken. So it contradicts that the quiz will be
नहीं
surprised.
नहीं, एक्चुअली मैंने गलत तरीके से बताया. So when the teacher on the Friday, last Friday, said ki I will take surprise quiz next week, then students met on week end and they tried to eliminate days on which surprise quiz cannot be taken. So on the discussion, they found that Friday in any case cannot be a surprise quiz because उसके पहले 4 दिन quiz नहीं हुआ and therefore the probability of taking quiz on Friday is 1 and then it is not a surprise quiz. So Friday in any case quiz cannot happen. If Friday cannot happen, then only 4 days are remaining: Monday, Tuesday, Wednesday, Thursday. With the same logic, if Monday, Tuesday, Wednesday quiz is not conducted, then Thursday cannot happen. Quiz cannot happen on Thursday. So Thursday is also eliminated. So by process of elimination, they calculated that the only probable day of the quiz is Monday, and therefore Monday also cannot be a surprise quiz. उस तरीके से
Sir,
उन लोगों ने सैटरडे या संडे डिसाइड किया. हाँ बोलो.
one more question. Is this a type of question which like that self-referencing statement that if there is a statement that this statement is false, so if we put it as true, the statement it itself become false, and if we put it as false, the statement becomes true.
नहीं, ये नहीं है. बहुत सिंपल सी फैलेसी है इसमें, बहुत ऑब्वियस एंड सिंपल.
Okay.
Sir, can I try?
बोलो.
Sir, the teacher might calculate when the students will least expect the quiz to happen.
अरे मैं लॉजिक की बात कर रहा हूँ, तुम लोग
Sir, can I? Hello. The teacher said that he will take in next week. So how it can be surprised?
नेक्स्ट वीक
He
में
given
छुट्टी
the
5
time
दिन
frame.
है. There are 5 days. So any of those 5 days could be a quiz and therefore it is surprise quiz. में क्या दिक्कत? चलो सोचना, मैं अगले क्लास में बताऊंगा. So let me start recording. Okay, so last class we were discussing about that at nano scale we should expect the unexpected, and for that we started with discussion on Moore's law, which came in 1965, and we referred to some of the examples of the current state of the art of VLSI industry, which we have reached up to 3 nanometer technology. And that 3 nanometer technology I defined in the last class that it is basically the gate length of a semiconductor device or a transistor. So length between a separation between source and drain. So in the source is a source of either of the two carriers, electrons or holes, and when it drains to or when it moves to balance it out the direction of drain, then it passes through the gate. That gate length is this 3 nanometer or 5 nanometer or 9 nanometer, whatever was the technology. Okay. So currently our industries are working at 3 nanometer technology. In your mobile phone, most of the mobile phones, there are devices following 7 nanometer technology. All such type of examples we know. And what is the advantage? That also I told you that if I can't increase the speed of these carriers, electrons per se, let us assume, then the only way to get a faster switching action is to reduce the distance between two terminals. And to reduce that distance is basically reducing the gate length, and that gate length we are reducing, and therefore we are getting faster and faster switching action, and therefore we are getting faster and faster logic circuits. Therefore, we are seeing immediate action to our requirement. Okay, so this is what we are seeing at this nano scale, and now we are moving ahead or moving towards defining what is nanotechnology. So the first transistor that came into existence was 4004 by Intel, and now the same Intel in 2017 has created a transistor of 1.75 processor of 1.75 billion transistors on it. तो जो हमारा डाई साइज है जो हम 1 इंच स्क्वायर के फॉर्म में कंसीडर करते हैं, so on that 1 inch square, the earlier version, the first version had 2300 transistors. The current version has 1.75 billion transistors, so 1.75 into 10 power 9 transistors. Or 9 transistors. So this is the advancement that we have or that we saw in last 50 years. And all these advancements are actually being studied or considered or mapped along this Moore's law. So Moore's law now is not seen only in terms of VLSI industry. It is also seen in many other fields. And we are finding that it is fitting pretty well in all those fields. That the size of the device or size of whatever of that parameter is reducing by half, and the cost is also reducing by half. And this is the driving force behind the market. And therefore, so far, we have not hit the wall. But now again, first time it was considered in 2003 that we have hit the wall. 2003, Moore was invited to a conference of IEEE SC, Solid State Circuit Society conference for a plenary talk in which he explained why he thinks that now industries would not progress at the same pace, but it was too difficult to say or call it a date. But even after that, more than 15 years are gone, and still we are not seeing any end to it. So we discussed about all this in the last class. So let us go back when the concept of nanotechnology theoretically came into existence. That happened in 1959, precisely on 29th December 1959, when Richard Feynman gave a talk on the topic written here, there is plenty of room at the bottom. And his precise statement was that the principles of physics, as far as I can see, do not speak against the possibility of maneuvering things atom by atom. This was the statement made just on the verge of 1960. So 40 plus 22, so 62 years are gone. Of this possibility, theoretical possibility, that you can go down and down up to atoms, and there is no restriction on that, because you know how atoms behave, so you can make any physical system using any atom, single atom or multiple atom. However, that time it was hard to believe that we can see an atom. It was impossible at that time to see the atom. Can anybody say when? Can anybody say even if now we can see an atom? See an atom means we have to isolate the atom and then only we can see. Can anybody say? If your answer is yes, then certainly I will ask how. How do you say or why do you say?
Sir,
Bolo?
I don't know about isolating it completely, but I remember once I had seen on net some article or something which did depict that scientists have pictured the hydrogen atom using a special type of microscope. I think so, electron microscope or some microscope it was. I don't remember exactly what, but they had managed to picture the hydrogen atom.
Any other answer? Any other answer? कोई नहीं. Only one attempt.
Sir, the question was, can we isolate an atom, right?
The question was, do you confirm that we can isolate an atom? We can see. Question was whether we can see an atom. I said that for seeing an atom, you have to isolate an atom. Otherwise, how can you see?
Sir, for isolation, I have read that there was a machine which can isolate an atom and use it in a particle accelerator. Like in particle accelerator is a different concept, but there was a machine where they can isolate an atom and use it in a particle accelerator to convert into the energy. So if we can isolate the atom, then we can definitely see through in electron microscope then.
Hello, sir.
So that machine is called optical tweezer.
Optical tweezer.
Optical twister, like
Yes, it uses some sort of laser to hold atoms.
so the concept of isolating was that it uses three atoms, and then the atoms are collided and two atoms convert into a molecule, and the third is left as an energy particle. So that energy particle is isolated, and then it was used as for energy in particle accelerator.
I think, sir, we cannot see a single atom because the most precise microscope we have is the electron microscope, and its wavelength is way higher then the radius of hydrogen.
अच्छा ये बताओ, can anybody tell what is electron microscope? On which principle does electron microscope work?
Electron microscope works on the principle of like where electron is moving in a wave form, and we observe the its wavelength and frequency, some sort of
हाँ क्या क्या ये बताओ। अच्छा चलो और बेसिक में जाते हैं। on which principle do we see? हम कैसे देखते हैं? देखने के लिए क्या होना चाहिए?
Reflection of sun
रिफ्लेक्ट
rays.
होके आई में
Reflection of what?
from the
Light.
thing.
from the object that we want to see.
Entering of the light that is reflected from the object.
Sir, photon should strike our eyeball.
तो दिखने के लिए एक ऑब्जेक्ट तो होना जरूरी है जिसको हमको देखना है। दूसरा एक सेंसर होना जरूरी है जिससे हम देखेंगे, राइट। एंड देयर शुड बी सम सोर्स, जो जिसको तुम कह रहे हो कि लाइट रिफ्लेक्ट होना चाहिए, सो सम सोर्स ऑफ एनर्जी जो रिफ्लेक्ट होके आपके पास आ रहा है एंड विच कैरीज द इंफॉर्मेशन अबाउट दैट ऑब्जेक्ट, राइट और नॉट?
Yes, sir.
Yes, sir.
Yes, sir.
ओके, तो ऑब्जेक्ट होना जरूरी है या एक टारगेट होना जरूरी है, एक सेंसर होना जरूरी है। इन केस ऑफ ह्यूमन बीइंग दैट सेंसर इज आवर आई, राइट। अलग अलग एनिमल्स के आईज की कैपेसिटी, सो सेंसिंग कैपेबिलिटी अलग अलग है। एग्री और डिसएग्री? Therefore, some animals
Yes,
are
sir.
nocturnal animals जिनका IR विजन है, रात में देख सकते हैं, अंधेरे में भी देख सकते हैं। Some birds like eagle, eagle के देखने की कैपेबिलिटी डिफरेंट है than a cat, right? हाउस फ्लाई के देखने की कैपेबिलिटी डिफरेंट है फ्रॉम ह्यूमन बीइंग, राइट और रॉन्ग?
Yes, sir.
हाउस
Right,
फ्लाई
sir.
कैसे देखते हैं? what is that makes houseflies eyes different from human beings?
So the houseflies can see 360 degree.
See what?
Sir, the housefly can see in all the direction at the same time.
Yes, sir.
तुम्हारी आवाज कट रही थी। इसने यस सर कहा, वो बताओ क्या बोला इसने?
Sir, housefly can see in 360 degrees.
In 3 different
In 360 degree view, like they got.
in 360 ना, इतना भी मत बोलो यार। 360 में कैसे देखें?
हाँ सर, almost 20 से 200
मतलब सर ऑलमोस्ट, मतलब पूरा आज सर एक बार में उसको पूरा पिक्चर देख लो।
नहीं नहीं, ऑलमोस्ट ठीक है, बट ऑलमोस्ट का क्या मतलब है? 180 डिग्री इज 360 डिग्री, 200 डिग्री इज 360 डिग्री। ऑलमोस्ट का क्या मतलब? 360 के लिए तो के आई बॉल को बिल्कुल स्फेरिकली और उसके बॉडी से बाहर होना पड़ेगा ना। 360 का तो मतलब हुआ कि पूरे बॉडी के अंदर भी वो देख रहा है। नहीं नहीं, मतलब इतना एक्सैजरेट मत करो, बट नहीं तो a pigeon can also see, उसका भी angle of vision is quite large, and owl उसका भी angle of vision जो है बहुत ज्यादा है, and that is because owl की तो बिल्कुल आंख, if you can stare at or see the eyes of owl, it is protruding from
And
its.
sir, owl can flip a snake almost 180 degree backside.
Sorry,
And,
owl
and
can
owl
flip.
can, its neck almost 180 डिग्री बैक साइड मतलब पूरा पीछे घुमा सकता है अपना सर.
सर ना,
Yes,
बट सर की बात कहाँ हो रही है? वी आर टॉकिंग अबाउट आईज, और रादर वी आर टॉकिंग इन जनरल अबाउट सेंसर्स. बिकॉज सेंसर्स इसलिए मैं बार बार कह रहा हूं क्योंकि उससे हम अब निकल के आते हैं बाहर कि द सीइंग कैपेबिलिटी ऑफ अ ह्यूमन आई इज लिमिटेड. तो हम 400 माइक्रोन 500 माइक्रोन से छोटी चीज नहीं देख सकते. Therefore, our limit is human hair, जिसका width is around 500 micron or 600 micron. Human hair बहुत thin अगर human hair है, and single human hair is lying on the surface, you may not see that. You may not see that क्योंकि वो तुम्हारे इससे beyond है. So there is one term that is called resolution. So it depends upon the resolution of that sensor or human eye or any animals or birds eyes, जिसके बेसिस पे वो किसी चीज को डिस्टिंक्ट देख सकते. उस रिजोल्यूशन को अगर तुम ऑप्टिकल कंटेक्स्ट में समझना चाहते हो, देन the image that forms from interferometer or interference, याद आ रहा है? डबल स्लिट इंटरफेरोमीटर.
yes, sir.
Yes, sir.
जिसमें हम कंप्लीटली रिजॉल्व्ड और नॉट रिजॉल्व्ड, तीन तरीके का हम ये ग्राफ पढ़ते थे कि हाउ टू ऑब्जेक्ट्स आर कंप्लीटली रिजॉल्व्ड और नॉट एट ऑल रिजॉल्व्ड एंड जस्ट रिजॉल्व्ड. तो जस्ट रिजॉल्व में अगर देखोगे तो वी वे आर फाइंडिंग टू डिस्टिंक्ट पीक्स, और पीक का मिनिमा बहुत नीचे ग्राफ में 0 लेवल तक आया हुआ है. नॉट एट ऑल रिजॉल्व में दो डिस्टिंक्ट पीक तो हैं, बट उनका मिनिमा पीक के बिल्कुल क्लोज है. देयरफॉर यू कैन नॉट मेक आउट वेदर दोज रिफ्लेक्टेड रेज आर कमिंग फ्रॉम टू डिस्टिंक्ट ऑब्जेक्ट. तो मे से कि वो एक ही चीज है. So this resolving power of an eye or of an object or a sensor depends upon many things. One of them is angle subtended by the reflected ray that is coming from the object. और इसलिए अगर वो आपकी आंख के बहुत पास है तो आप देख सकते हैं, आंख से बहुत दूर है तो आप नहीं देख सकते. But again, distance of clear vision is, I think for human being is 25 centimeter. तो अगर 25 सेंटीमीटर से क्लोज किसी चीज को ले आओगे तो अगेन यू कैनॉट सी. So there are various factors and interesting facts, scientific facts, which gives you an idea how you can see. From there you can understand why you cannot see an atom, because एंगल सब एटम अपने आप में ही इतना छोटा है. एंगल सबटेंडेड बाय द बोथ बाउंड्रीज और द डायमीटर ऑफ एन एटम ऑन योर आई और ऑन एनी सीइंग ऑब्जेक्ट डिवाइस इज सो स्मॉल कि आप नहीं देख. नाउ सिंस when we see, we usually use this optical spectrum, visible spectrum, that too, to see. और इसलिए जब भी, जैसे अभी भी जब मैंने पूछा तो many of you replied that we require light for that. Light is the visible spectrum of electromagnetic spectrum. there could be other wavelengths also that we can use, not through your human eye, through something else, or there are other mechanisms. अदर मैकेनिज्म में ऑप्टिकल माइक्रोस्कोप उसके बाद हमने बनाया, क्या करता है कि अगर कोई ऑब्जेक्ट आपकी आंख से बहुत दूर है, बिकॉज ऑफ दैट इट कैनॉट सबटेंड एंगल which is resolvable by human eye, so it brings that object closer. It seems, it appears that the object has come closer to your eye, and therefore it makes now a bigger angle which you can resolve. और वो क्लोजर लाने की जो कैपेबिलिटी ऑफ एन ऑप्टिकल माइक्रोस्कोप इज नोन एज मैग्निफिकेशन, एंड वी कैन मेक 10x 100x magnification optical microscope that is usually used in biology labs or in pharmaceutical companies or in pathology labs for medical purposes. That also we are very familiar with. Again, in that, this visible spectrum of light is used as the source of light. जो ऑब्जेक्ट से जाके इंसिडेंट होता है, उससे स्कैटर या रिफ्लेक्ट होता है, और रिफ्लेक्ट होके वापस आई पीस में कलेक्ट होता है, एंड दैट कलेक्टेड रे विल गिव यू द इमेज ऑफ दैट ऑब्जेक्ट दैट यू आर ट्राइंग टू सी, एंड उससे हम सेलुलर लेवल तक देख सकते. बट ऑप्टिकल माइक्रोस्कोप हैज ऑल्सो अ लिमिटेशन. उसके लेंस का अपना लिमिटेशन है, जो ग्लास का बना हुआ है, उसके जो हम विजिबल स्पेक्ट्रम यूज कर रहे हैं उसका अपना लिमिटेशन है, उसका अपना वेवलेंथ है. एंड इफ यू रिकॉल द रिजॉल्विंग पावर ऑफ एनी डिवाइस और एनी ऑप्टिकल इंस्ट्रूमेंट that you might have read in your 12th standard or 11th standard, it takes care, or it is depending upon wavelength of light also. Lambda dependent होता है. तो मटेरियल वहां पे है और यहाँ पे लैम्डा है, जो दोनों रिलेटेड है. Therefore you can combination of material property and lambda makes your device, whether you can see or not, whether you can use that material as the lens or not. Many material are transparent for a large wavelength जो हमारे पास दिया हुआ है, ऑप्टिकल वेवलेंथ, और इसलिए हम बहुत सारे मटेरियल यूज ही नहीं कर सकते हैं फॉर आवर माइक्रोस्कोप. Then it was thought, and why can't we use electrons as that wavelength source? तब तक वो सारी थ्योरी आ चुकी थी, वेव पार्टिकल ड्युअलिटी की थ्योरी और क्या डी ब्रॉगली वेवलेंथ की थ्योरी, वो सब आ चुकी थी, सब पे नोबेल प्राइज वगैरह शायद मिल चुका था. सो वी वर कॉन्फिडेंट दैट एन इलेक्ट्रॉन may behave as a particle at times and may behave as waves at times. So what will happen if we take electrons as the source of wavelength for seeing? And that gave birth to a new instrumentation that is called electron microscopy. In electron microscopy, we don't use optical wavelength for seeing, electron wave for seeing. Since it is electron waves, therefore the wavelength I can tune. क्योंकि वहां पे फिर वो कितनी एनर्जी का वो इलेक्ट्रॉन बीम हम यूज कर रहे हैं, that energy will determine the wavelength of that electron beam. These two are related. Kinetic energy of that electron beam will ultimately tell you or will get converted into corresponding lambda. Now, since I am manipulating or I am actually creating that lambda, tuning that lambda, so my resolution or resolving power of that device is now much more than what we can get from optical sources. क्योंकि ऑप्टिकल सोर्स में मटेरियल बिकम्स अ हिंड्रेंस, अ लिमिटेशन, क्योंकि बहुत सारे मटेरियल के लिए वो वेवलेंथ ट्रांसपेरेंट, मतलब बहुत सारे मटेरियल वे ट्रांसपेरेंट फॉर अ लार्जर रेंज ऑफ दैट वेवलेंथ, ऑप्टिकल वेवलेंथ। तो स्कैटर होके या रिफ्लेक्ट होके मुझको मिलता ही नहीं, तो मैं नहीं देख सकता हूँ फॉर स्मॉलर वेवलेंथ, जिससे मैं ग्रेटर रिजोल्यूशन ले सकता हूँ। इलेक्ट्रॉन बीम के केस में आई कैन टेक एनीथिंग और उसको एक दूसरे इंस्ट्रूमेंटेशन मेथड से, उसमें फिर आंख से मैं नहीं देख रहा हूँ, आई डोंट यूज आईज, so I replace my eyes with a typical responding sensor, जो उस इलेक्ट्रॉन बीम को एनालाइज करके मुझको इमेज कन्वर्ट करके देगा। तो इस इलेक्ट्रॉन माइक्रोस्कोपी पे the theoretical work was done long back in 1930s. But the Nobel Prize for electron microscopy was given in 1986, almost after 50 years. Almost after 50 years. So, and that the same year, there is another microscopy that was given Nobel Prize for, and that is called scanning tunneling microscope. Devices are on two distinct ideas. Two distinct ideas. In case of electron microscope, as I said you that it uses electrons as wavelength source, and it can be used in two forms. One is in which it gives you only information about surface, and that electron microscope is called SEM, or scanning electron microscope. Scanning electron microscope, SEM or SEM, it is called SEM. Another type of microscope, electron microscope, is TEM, TEM, and this T stands for transmission. It penetrates through the layers of the material, comes back and tells you about each layer. जहां जहां भी atom है, तो crystal structure में अगर देखते हो तो there are repeated structures. So the electron wave, some part of electron wave will get reflected from the surface, another will get reflected from the first layer below surface, another will reflect from the second layer below surface, and it transmits through till the end of the material and comes back. All these waves interfere and ultimately give you the image of that solid which it penetrates or transmitted through. Because of that, it is known as transmission electron microscope, TEM. Obviously, the energy of transmission electron microscope, energy of electron beam of TEM is much more higher than that of SEM, क्योंकि SEM में मुझको केवल surface का information चाहिए. My electron beam does not require to penetrate into the solid or into the material, जिसको भी मुझको see करना है, देखना है. But in case of transmission electron microscope, it has to transmit through, and therefore it requires more energy. Simple logic. But electron microscope gives me an image, statistical image of surface or the complete meat of the body, material. स्टैटिस्टिकल पिक्चर देता है, तो उससे मुझको क्रिस्टल स्ट्रक्चर मिलेगा, ये NaCl का क्रिस्टल है या ये HCl का मटीरियल मीडियम है. But it does not tell me exactly where atoms are put. Or if you recall, 2 classes ago, there was a slide in which I showed you one perfect cube made of cubical atoms, and in the other cube there were some defects or some missing cubes also. याद आ रहा है, जिस पे हमने numbers लिखे हुए थे, which cube
Yes,
is
sir.
touching how many faces, or which cube has how many free faces. That time we were discussing about reactivity happening on the surface, और हमने कहा था कि each atom has different type of reactivity. Ultimately that is calculated in terms of chemical energy of the surface or of the material. में हमने ये बताया था कि there could be a situation when there we find some defect in that crystal. It is not a perfect cubical crystal. Those defects are missing locations of those atoms. So electron microscope does not tell me exactly where some particular atom is missing. और जैसा हमने आपको एग्जांपल दिया था, 6 gold atoms nano switch और 20 gold atom nano switch, उसमें जब मुझको बिल्कुल precisely I have to put one particular atom at one particular location coordinate, it is impossible for electron microscope to figure out that where I have to put that atom. और जब तक हम वो फिगर आउट ही नहीं कर पाएंगे तो हम रखने का तो कोई तरीका हो ही नहीं. Electron microscope did not give us, even though it was there since 1936, it did not give us, or it has some limited utility. In 1985, 2 of IBM engineers came forward. They were studying something else. And then they came up with a great idea of seeing precisely location by location in a crystal, in a solid, how these atoms are placed by measuring the current that passes through some device on the surface of that material which they were studying or which you intend to study. And that device is called scanning tunneling microscope, STM. Within 1 year, they got Nobel Prize for that work because it was actually a breakthrough. It revolutionized our seeing capability. Both for electron microscope and for scanning tunneling microscopy. स्कैनिंग टनलिंग वाले को 50% मिला, इलेक्ट्रॉन माइक्रोस्कोप वाले को 50% मिला. मैं नाम भूल रहा हूँ उस नोबेल लॉरेट का. कोई गूगल सर्च करके बताएगा? Nobel Prize in Physics in 1986. There were 3 people. 2 were for STM, 1 was for electron microscope. Who was that one guy?
Sir Ernst Ruska, then
Right. Ruska. Yes, Ernst Ruska was the guy who got. और ये interestingly, This was his work for his PhD thesis. Can you beat it? Just 50 years ago, when he was doing his PhD, he submitted to his university. Anyway, so this is about seeing capacity. Coming back to this definition, or the key point or key message of Feynman's lecture or talk presentation on 29 December 1959, that he said that no law of physics restricts you from working at atomic level. Just so happened that we are not working in that direction, but if you want to work, we can. And this talk is very, very interesting. I very strongly suggest you to go through this talk. If possible, I will put it on Moodle also. को पढ़ना जरूर, बहुत ही interesting talk है, in which he actually theoretically he explained how the complete Encyclopedia Britannica can be written on a paper pin or paper pin head. Complete Encyclopedia Britannica. We have the capability of writing at nano scale. So he explained it. It was a thought experiment. It was a theoretical explanation, a description to write that. So he discussed about various possibilities. Now it was for the world to respond to his direction, which we tried and which we achieved in many sense, which we did not achieve in other many senses. So after that talk of Feynman, the first time the term nanotechnology, Feynman did not use the term nanotechnology. The first time this term was used was in 1974 by Norio Taniguchi, Japanese scientist, physicist. I have given reference to his paper also. This paper, he mentioned the term nanotechnology. He said that nanotechnology mainly consists of processing of separation, consolidation, and deformation of material by one atom or one molecule. Till that time, also, we could not do any experimental. There was no experimental or demonstration of working at atomic or molecular level. So then further what happened? In 1992, look at the time period. Look at the time period after 32, 33 years. Again, this work was theoretical work. That Eric Drexler wrote a book on the various possibilities of at nano scale if we have the capacity to work at nano scale. At that time, he talks about many mechanical gadgets using molecules and atoms. तो मशीनरी मैन्युफैक्चरिंग इन सब की बात उसने ज्यादा इस बुक में की एंड दैट वाज अ बुक थ्योरेटिकल बुक जैसे गियर शाफ्ट सब तरह के मैकेनिकल टूल्स की were referred in this book. So he also discussed about possibilities if we have the capability to work at nano scale. As per Eric Drexler, in that book he defined that nanotechnology is the principle of atom manipulation. Full of atom manipulation, atom by atom, through control of the structure of the matter. ऐसा नहीं है कि मैटर चेंज हो जाए, जब तक हम उस पर काम कर रहे हैं, इफ द मैटर एक्चुअली चेंजेस इटसेल्फ, तो फिर कंट्रोल नहीं रहा। At the molecular level, it entails the ability to build molecular systems with atom by atom precision. Exactly 5 एटम रखना है या 9 एटम रखना है या 12 एटम रखना है या 20 एटम रखना है, that is the design, or the designer had to decide, and manufacturer will build just like that. For example, अभी जैसे मैन्युफैक्चरिंग में हम करते हैं कि इफ यू हैव टू बिल्ड अ कार, देन दिस इज इट्स ट्रांसमिशन, दिस इज इट्स गियर सिस्टम, दिस इज इट्स कंट्रोल सिस्टम, दिस इज इट्स फिजिकल कॉम्पोजिशन कि 4 टायर होना है, एक एक्सेल होना है, इस तरीके से उसमें स्टीयरिंग होना है. So all these are decided and fitted also. Similarly, at nano scale, when we are making some device, then it should be at atomic precision level, yielding a variety of nano machines. So what he indicated, that at nano scale we have to be very, very precise. अभी के मैन्युफैक्चरिंग प्लांट जैसा नहीं कि जो बचा वो स्क्रैप में चला गया, चलो इसको ऐसे काट दो. आप यू टेक, I don't know whether you go to tailors or not, but if you take 2 meters of cloth to a tailor, he will stitch a full sleeve shirt for you, but there is a lot of, so at least 10 to 20% of the cloth is actually wasted. जो इधर से कट के निकल गया, उधर से कट के निकल गया, and it all goes into waste or scrap. So in the current manufacturing world, we are ruthlessly wasting material, but at nano scale, it is not possible because we are at atomic precision level. At the most, we can waste 10, 15 atoms. So that is the beauty of working at nano scale or working at atom by atom precision. In 1989, this is the first demonstration of our capability of writing at nano scale. And remember, just now I told you that in 1986, there was a Nobel Prize in Physics on STM, scanning tunneling microscopy, which enabled you to see at nano scale or atom by atom. That was done by 2 IBM guys. So the another IBM guy, Don Eiler, he immediately wrote or designed or created IBM logo. Using 35 xenon atoms on a nickel substrate. So the gray rectangular flat surface is that nickel, and these blue hill type structures are those xenon atoms. And if you count, these are 35 atoms. And he wrote IBM. IBM logo is just IBM. So he wrote IBM. And he demonstrated that yes, in this way we can move atoms atom by atom. जहाँ मुझको रखना है वहाँ मैं रख सकता हूँ, जहाँ से मुझको हटाना है वहाँ से मैं हटा सकता हूँ. And this was done using that STM. So this was the first demonstration of working at nano scale or atomic scale. So to put all these things together, a comprehensive definition of nanotechnology could be this. Nanotechnology is concerned with developing the tool. सबसे पहले मैं tool develop करूंगा जिसमें I can move atoms or I can pick and I can drop atoms wherever I want for characterizing and manipulating materials. तो pick and drop मैं कर सकता हूं, मैं बता सकता हूं, I can tell you how many atoms are there. So characterizing is also possible. Picking and dropping is possible. So manipulating of material is also possible on nanoscale. And that nanoscale is defined in the range of 1 to 100 nanometer because 1000 nanometer is micron and that comes under micron scale or micrometer scale. And therefore, the boundary of nanotechnology was decided from 1 to 100 nanometer. 1 के नीचे चले जाओगे तो एंगस्ट्रम में चले जाएंगे, तो एक दूसरा स्केल है. हमारे स्केल में हम मिलीमीटर तक हैं, मिलीमीटर के नीचे माइक्रोन गया 10⁻⁻⁶, उसके नीचे नैनो आया 10⁻⁹, उसके नीचे पीको आया 10⁻12. So the boundary of nanotechnology or nanoscale is 1 to 100 nanometer. That is quite understandable. And so exploiting these tools for what? What is the objective for exploiting these tools? Not for fun, but for the development of new products and processes. So kindly note this highlighted bold red letter word, new products and processes. जैसे मैंने आपको कुछ एग्जांपल्स जो इसके पहले दिए, even though we used gold atoms in that circuit, in that switch, it became insulator. Even though we use rubber, I can make rubber conductor. I can make copper insulator at nanoscale. I can make clothes at nanoscale which are non-wetting. I can make clothes at nanoscale which using which you can climb on the wall. So these are the new products and processes. So unless you are producing new product, it may not be considered under nanotechnology. The flip side is that. So if you want to define what describes nano or what is the boundary of nanotechnology, then narrow definition is that at least 2 dimensions of that solid. Nanotechnology talks only about solids. So fluid के case में it is very difficult to define the boundaries of that material. कौन सा atoms or molecules are changing their position, shape all the time. So narrow definition of nanotechnology or nanoscale or nanomaterial, nanoproduct is that at least 2 dimensions are below 100 nanometer. And extended is that at least 1 dimension is below 100 nanometer and a second dimension is below 1 micron. And the third dimension could be in meter also. And therefore carbon nanotube is an example of nanotechnology. क्योंकि कार्बन नैनोट्यूब का जो डायमीटर है दैट इज अंडर बिलो 100 nanometer or sub 100 nanometer dimension, and rest are in millimeter, centimeter scale. So once having understood what is the boundary of this nano material, Now we can define three things. What is a nanostructure? So nanostructure is that is completely defined by their geometrical dimension with reference to an external reference system or substrate, like अभी जो हमने दिखाया आपको IBM का logo, that is lying on the nickel substrate. So that was the substrate. In that respect, those xenon atoms were nanostructure. Nano device, at least one functional component is a nanostructure. Now, functional component is very important. Otherwise, there are atoms everywhere, there are molecules everywhere. So you can say, you can argue that why not we consider these also nano device? No, those are not functional components. If main characteristic of the product that you have designed is getting driven by that nano device, meaning that particular nano device is the functional component for deriving that special characteristic of that nanostructure or nano design. So functional component होना बहुत जरूरी. And what is a nano system? Nano system consists of several nano devices that are of importance for the functioning of the whole system. So even a car of today can be a nano system if you are using several nano devices in the car to give the car a different type of characteristic functioning. तो हमेशा जरूरी नहीं है कि नैनो डिवाइस या नैनो सिस्टम को बिल्कुल नैनो स्केल पे ही होना है, which you cannot see. This is a misnomer. And in earlier days, in beginning of 21st century or at the end of 20th century, people were afraid of this working in the direction of nanotechnology because they thought that all these nano devices are in form of robots or nanobots, which you cannot see, and they can control you in a shorter time or duration. But that is a misnomer. Even your mobile phone can be a nano system. If there are some nano devices which are giving that mobile phone a different flavor, a different type of functioning, which is not else otherwise is seen or perceived or obtained. So let us spend 5 minutes before concluding today's class on this discussion. We started today's class that there are fab labs who are announcing that they are working at 3 nanometer scale. There are mobile phones which are using 7 nanometer microprocessors. So all these are within the boundary of definition of nanotechnology, 0 to 100 nanometer. So do you say or do you agree that the current state of the art VLSI technology is an example of nanotechnology? बताइए, आप लोग कुछ लोग इस पे कमेंट कीजिए. Anybody? बोलो भाई, सही गलत कुछ भी हो सकता है. Don't hesitate in that. Is the current or is the state of the art VLSI technology an example of nanotechnology? Do you consider it nanotechnology? Hello?
Hello.
Yes, sir. Like,
Bolo.
Sir, some of the things are yes and some no, because some processor do use some high performance techniques. They do maneuver the atoms, like they are maneuvering one single silicon atom, or that shall be considered nanotech. But some do not. Like they are just making it small, but not maneuvering the things. Then it should not be considered.
Any other answer? Any other answer?
Sir, I think the answer should be yes, because in the realized technology, the silicon atoms are so arranged so as to manufacture the 3 nanometer MOSFET devices, and that is a product. So that should be considered, and the scale is 3 nanometer by 3 nanometer. So 2 dimensions are in the range of 1 to 100 nanometers. So it should be considered as an example of nanotechnology.
Any other answer? Any other answer? नहीं? So you missed a major point in when I was defining nanotechnology, and that major point was highlighted, was in bold and in red font, and that was that it has a capacity or capability of giving you new products or features. For example, making gold an insulator. For example, making rubber conductor. Making carbon wires which has more tensile strength than steel. in today's VLSI technology, we are not getting a new property material, whether it was 0.18 micron technology or it is 2 nano, 3 nanometer micron nano technology. It remains the same. Silicon behaves same. Transistors behave same. Logic gates behave the same. We are not getting any new product out of that. It is an example of miniaturization and not example of migrating from micron technology to nanotechnology. And therefore, it is not an example of nanotechnology. Okay. So with this, today's class ends. Let me stop recording. Stop sharing. And let me allow you all to escape, disappear fast from the class. But anybody
hello,
has
sir.
any question? Hello? Somebody was asking something.
Sir, can I try that quiz question? Like, I think I got the
Which quiz
mistake.
question? हाँ बताओ.
That you asked.
हाँ, tell me.
So, for the first time, they are considering that for the first 5 days, it is not happening. Then the 6th day, the probability will be 1. So, uh, at that time, they are correct. But while applying applying it on for the next day, they are considering that the probability, the probability, they are taking conditional probability, which is not true. Like, they are considering that it will not happen on Saturday, and if it is not happen on the first 4 day, then the probability of happening it on the 5th day will be 1. But they should not go in that way. Like, if it is not happen on the first 4 day, then the probability of happening it on the 5th day will be 1 by 2. So since they are taking the conditional probability, like, if uh, given that the quiz has not happened on the 6th day, and if the quiz has not happened on the first 4 day, then the probability of happening it on the 5th day will be 1. So I think that was their mistake.
So you are probably on the right track that conditional probability should not be considered here. You cannot eliminate other days while calculating probability of some particular day.
Yes, sir.
Okay, so Celia, thank you very much. So now I am closing today's class.